Hello, everybody. Thank you so much for joining us for today's London Java Community event with Oleg. Let me introduce myself, first of all. For those of you who don't know me, my name is Abby, and I work with the LJC and a number of other communities, all of which are free for our members and run by RecWorks. Excuse me. So RecWorks are a tech recruitment company with a huge difference. Obviously, as a company, we're always on the lookout for more clients, and some of our best clients have actually come from community members who recommended RecWorks to their internal talent team. So if you're hiring for a new team or you're working for a company that is, we would love to have a chat with you. And if you'd like to know more about what we can offer on that side of things, just send me a message on LinkedIn or Slack, and we look forward to working with you. So what's the difference, I hear you ask? Well, also, we really do believe that recruitment can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to share their knowledge, we are more than happy to connect you through our communities and events like the one today. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run hundreds of events for engineers, developers, students, graduates, CTOs, the list goes on. We have run conferences, lightning talks, hackathons, all sorts. Earlier this year, we made our 5,000th introduction through our Meet to Mentor community, and we're really looking forward to seeing what happens next in that space. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our communities, again, get in touch with myself or Helen Lewis if you know her, and we can take it from there. Just to let you know, today's session is being recorded and it will be available on YouTube. I will put the link to the channel in the chat during the event for you. And if you have any questions, feel free to put them in the chat, but there will be time for Q&A at the end of the talk. So with no further ado, I'm going to hand over to Oleg. Over to you.
Thank you, Abby. Let me share my screen with presentation. So yeah, I hope you see my presentation. Okay, first of all, thank you, Abby, for opportunity to give my presentation to London Java community. I really appreciate. I think it's really important to share your knowledge. So I hope that participants would see that's very helpful. Okay, so this presentation about microservices and whether they are good, what's the obstacles with microservices and why do we need them at all, and we're going to talk about also about monoliths. Let's first start about myself. So I'm Oleg, I am a software engineer, so I have experience about 10 years. Mostly I worked in financial organizations, and I did a lot of roles, engineering, leading, architect. You could find me on LinkedIn and on GitHub. Okay, that's enough for me. Okay, so we are going to talk about monolith and their challenges, how we could solve those challenges, and what microservices and how they help us to solve those problems, and what problems we have with microservices. And in the end, we'll have questions and answers. I hope you'll have a lot of questions. By the way, during the presentation, you could write your questions into the chat, but I'm not going to answer this. I'm going to answer them at the end of the presentation. Okay, let's start with monolith. So what it is. So monolith, first of all, it is one repository. Let's say it could be a Git repository where you have all the sources for your project. And out of this one repository, you have one build. It could be different forms like image for Docker container, or jar, or many other artifacts for any other languages. And you could have only one deployment on the production. So let's say you can't deploy it partially, you could deploy only all at once or nothing. So you can't just change one particular code and deploy that particular code only. So you could deploy everything all at once. And most probably you're going to use the same, the one particular tech stack. Let's say it could be Java language or Go or any other languages, but it's in many cases, it could be only one particular technology. So you can combine several technologies into one monolithic architecture, into one monolithic deployment. And most probably you'll have one database where you have a lot of tables for your particular modules, and these modules could share the same database and they could read tables from different modules. So that's kind of a definition of monolith. And what the problem could arrive with monolith. So as engineers, we always need to remember that we should support our businesses. So if businesses is growing, then company is growing, then our salaries is growing, and we have more engineers in the company. And with growing the business, we have more complex business logic. Let's say we have we added additional flows, we added additional logics, and with the time, it becomes harder to support it. And the important thing, we have to roll out our features in production very fastly, which means if we make our feature in production faster than our rivals, then most probably we will earn more money than our rivals. So it's very crucial to roll out our features faster than our rivals. And yeah, so that's we need to take in mind. We should bear in mind that we should support business, and we should, if business is growing, it's better for us, for engineers. Let's assume that we have a service, and there are engineers that support, build new features for that service, and there are customers that spend money using that service, and they receive goods. And and let's assume our business wants more features in our service. We have big Jira backlog for our services, and businesses saying you need to add features for catalog, for better for checkouted goods and services, for goods and services. And also, they also wanted to add information about customers, so customer could change their details, name, address, whatever. And for that reason, we need more engineers that should support our service. And here the problem arises. So what problem arises here? So if you have more engineers, it's harder to negotiate with each other who is doing what in the particular in the monolithic architecture. So, and as the outcomes, it becomes slower to develop new features. And let's say if we had a bug in our service, you need to roll back everything at once, so you can't just partially roll back that particular bug, and it's really a problem for our services. And another thing is support. So who should support our services? Who should be on call? Who should fix those features? Who should fix that problems? It becomes really a problem. It becomes really a problem. And so yeah, we have problem with responsibility in that way how we develop the monolithic service. And how this problem could be solved? So we could split our service into domains. So let's say we are saying that we split on, in our particular examples, we split on 3 domains. So we are saying that we have customer domain, we have domain for the cart, and we have domain for the catalog. So, and we have each individual team that is going to support their particular domain, and they have their particular tasks in their backlog. So it becomes much easier for supporting that service. But still, it's this monolithic architecture. And in order to make it much better, we should split our service on independent microservices. So we have fully independent teams that support that particular service. They have their independent database, so they can do whatever they want with their service, and it becomes much easier to develop new features. Okay, so, but let's say business is telling that we need to build additional features into the catalog. They say they need recommendation systems. They need comprehensive recommendation system where the customers could write comments, as they could add stars to particular goods. And we added this to our new, fresh, independent microservices, and the logic is very complex, and our team became bigger, and those teams need to support this big microservice as well. In that case, you need to split those growing microservice into two independent microservices. So as we see, we could split any services on any number of microservices very easily. But yeah, so what's microservices? So in our example, we see that those are loosely coupled services. So it means that if you make changes in one service, you don't have impact on any other services. And you have independent teams that are responsible for that microservices. In reality, mostly one team supports several microservices. Based on my experience, there are 1 or 2 services per person in the team. And you have independent builds, so which means you could roll out, roll back your services almost independently. In some cases, it's not true, but in most cases, it is true. And so services should talk with each other based on the API. Okay, so we know the definition of microservices, but it's not so easy to split service onto the independent microservices. And the reason is because it's hard to do that. For example, so you know these companies, Netflix, Amazon, Twitter, and in other companies, they're very big. You know them well. And they also started at the beginning with monolithic architecture. And at some point, they decided to split their monolithic architecture into microservices. And it took about, I don't know, years to split those monoliths into microservices. And so, for example, as I know, Amazon took about 10 years to do that, and they still didn't complete this. So they're still splitting their services into microservice architecture. And the reason why is it so? This is example of Amazon microservices. So you see that there are thousands of them, and so each red dot, it is microservices, and each line between those dots is how those services communicate with each other. So you see that they have thousands of microservices. They should communicate with each other, and the complexity of that, that's the reason why they took so long in order to split their services into microservices. Okay, the other thing you need to take into account is how your services should communicate with each other. So you could take 2 different approaches: synchronous, asynchronous. With synchronous, you should think about protocol of communication, payload format, and technologies that you want to use, whether it's HTTP or any other technologies. For asynchronous, you're going to use queues, topics, and most probably you're going to use Kafka or RabbitMQ, or maybe any other use. Also, you need to think about containerization. So most probably you're going to use Dockers and Kubernetes, and you need to build infrastructure in order to support your containers. So most probably you need to have dedicated infrastructure teams that will be responsible for supporting those services. So in big organizations, there are dedicated teams that are responsible for that infrastructure. They support, most probably it will be split on 2 different, there will be infrastructure team that support all other product teams. So product team, they don't think mostly about infrastructure, they should think about how to make products, and infrastructure team helps them to roll out their services into production. And what problems arises with microservices? First of all, as I mentioned, is infrastructure. So if you have 1,000 microservices, so it's harder to support it. you need to figure out how to do that. Also, you need to think about how services should communicate with each other. And another problem is monitoring. So if you had a monolith, you just have logs most probably in one place, and you know where to find particular logic. But with microservices, you need comprehensive monitoring. Okay, so if microservices are so good, so why you can just start and build everything using microservices? And the answer is it's not so obvious. So when you build monolithic architecture, it's much easier at the beginning because everything in one place, you don't need to think how to roll out. So if you have few logic, you don't need to roll out a lot of services into production. You just roll out one particular build. So if you start with microservices, you're going to spend a lot of time on architecture, and you'll spend a lot of time on the rollout and feature into production. But at some point, with the complexity of logic, microservices became much easier to support than monolithic architecture. And if you're not going to migrate to microservices, so you're going to support monolithic architecture, and it will be problematic for your product. So your development will slow down, so it will be hard to support it. So we will have all the problems that we discussed before. Okay, so but what if in some situations microservices are not so good as a monolithic architecture? And the answer is yes. So in some cases, monolithic architecture is much better. For example, just recently, I saw the article from Amazon Prime Video where they claimed that they migrated to monolithic architecture and they saved a lot of resources. They reduced cost by 90%, and they have more scalable, resilient system because of this. But if you look into details of that article, they didn't explain too much details about in that article. They need to write in more understandable way. But what they wrote here, that they said that they had services that send to each other video traffic, and they just convert the traffic somehow. I don't know in which way. And they had overhead because they need to send the traffic between different services. And what they did is they just combined those services into one, and they said this is monolithic architecture. So in that case, they had really overhead on communication services with each other, and therefore they decided to combine them into one. Okay, to sum up everything, so monolith is good for proof of concept. So which means if you're just starting your project, if you just started to build this, you don't know how it will end up. Maybe it will be a disastrous project, so maybe it will not give you money. So in that case, it's better to make it fast enough. In that case, monolithic architecture is the best choice. And with the time, it's harder to scale with microservices. So then you need to migrate to microservices architecture, and it became easier to scale, and you are going to roll out a feature much faster than your rivals. But the outcomes of this microservice architecture has the problems with communication. I mean, it adds additional problems with communication overhead. Okay, that's what I wanted to share with you. So please ask the questions.
Excellent. Thank you so much, Oleg. Has anybody got any questions? You can either put them in the chat or unmute and ask. That's absolutely fine.
No questions?
Sorry, I couldn't find the unmute button. You think after 3 years of a pandemic and doing remote working, we'd all know where unmute is by now. Excellent talk, thank you. I particularly like the graph showing the microservices premium at the start, because I think that's a very important thing that people don't realize. Microservices will not save the day at the start. But if you have microservices at the start and you know you're going to need them in the future, you'll save having to implement them. My question is on APIs and microservices. I use an environment where we have a front-end application and several back-end applications. And one of the problems is if the API service in the back-end changes in an incompatible way with the front end stops working and the back-end looks okay. So somebody looks at the front end. Have you had any experience of managing simultaneously running versions of the same API, and what would you suggest for somebody who needs to transition from maybe one version of API to another, and to release separate components at separate times?
So whenever you release new API, it should be supported by previous version, definitely. And I don't know any ways how you could roll out, let's say, backend and frontend at once. I mean, at the same time. So most probably you just need to support previous version, and you need to make sure that all front-end services migrated to new APIs, and you just switch off old API. So maybe that's only solution I know. So I don't know any other solution. I think there is no any other solutions. But it depends how you're going to change your API. For example, if you just add in new fields, you could just make some unnecessary. But if you just completely change it, so probably you just need support both APIs. So there is no any other solutions. At least I don't know them.
Okay, fantastic. Thank you.
Oleg, hi.
Yeah, go for it.
Yeah.
Thank you.
Sorry, can you hear me?
Yes, we hear you.
Okay, thank you. Oleg, I have a question regarding the premium microservice premium part of the part on the graph where it's represented where like on the productivity time scale. So can you please elaborate more on that idea of microservice premium? Is that like, does that represent some kind of a luxury to introduce microservices as a premium or something else?
You're talking about that particular article, or what you're talking about? So,
yeah, I like few slides back, I think. Yeah, the one
maybe that one.
No.
That one.
Yeah, that one.
Yeah. So in that case, if you just start your if you start with monolithic, so monolithic architecture, it means that your productivity will be faster at the beginning. So time means that with time you add more complexity to a service. So it's time not just passing time. It just means like years here, or maybe several years. So it means that with the time you add in more logic for your services. So we could just change it, not time, but like say complexity of your services. So in that case, if you just start with monolithic, it will be much easier for you to develop new features. If you start with microservice architecture, you need to roll out your features in the production for each particular microservices, and sometimes it will be additional overhead for you. So that means microservice premium here, it just it helps you to make features faster at the beginning.
So that's what you're saying for monolith, right?
Yeah, so let's say if you start with monolith,
process.
your productivity will be faster at the beginning. If you start with microservices, you need to think how to make architecture on this. You need to think how many services you should have, how to roll out them to production. So at the beginning, it will be your productivity will be much lower than for monolithic architecture. So with the time, you add more complexity, you add new features to your services. It became hard to support monolithic architecture because you have, let's say, thousands lines of code in one repository and in one build. But with monolithic, they have independent services. And at the beginning, it's harder to support it. But with the time, it becomes vice versa. It's hard to support monolith, but it's easy to support microservices.
I see. And what about the point at which Monolith is less productive than microservices. How do we determine that? What are the key factors for that?
Maybe key factors will be how many people in the team supported service and how fast you need to make the features. For example, if you have a big monolithic architecture that belongs to one particular team, but you rarely change the logic in that service, maybe it doesn't worth to split it to microservices. The main reason for splitting to microservices is how fast you need to roll out your features into production. Maybe that's so you need to, let's say you have features, you need to measure how fast you roll out the production. If they're really important, you're not so fast with that, then it's time to split your monolith into microservices. Maybe that's the answer of the question.
Yeah, makes sense. And is there any like best practice for that? Like, what is the usual number of people in the team, or like what kind of features?
Yes. Let's say we could use best practices, for example, from Amazon. So the best practice, the number of people should be enough for 2 pizzas. So let's say about maybe six engineers in the team. I think it's a good number. So it shouldn't be more people. And if you have several services per person, maybe 1 or maximum 2 per person. So I think it's a good number. If you have 3 services per person, I think it's time to split them. Maybe, but as I said, if services, you don't need to make changes, too many changes to your services. Maybe you just keep it as this. You don't roll out to production too many so often. They just keep it. But if you, so you just need to calculate maybe time to market. I can't say exact maybe numbers, but that's just a rule of the thumb.
Okay. Thank you.
Excellent, thank you. It looks like we've got another question. Go for it.
This is Earl Lancaster. Hi, Oleg. Thanks a lot for your talk. Could you perhaps share with us a little bit about security and microservices and indeed best practices for that? Because obviously things like passing tokens around thousands of services and things like that must become extremely complex to manage. What are the kind of best patterns that people use for managing security for kind of complex microservices?
Yes, so as I know, there are additional technologies that you could use. For example, you could use SPIFFE, where your service is authorized against SPIFFE, and other services check the requests and they see that this service is exactly from your infrastructure, and they could trust this. But okay. I don't know too many things about security, because in many cases, for example, in most companies, you have dedicated security teams that will be responsible for that infrastructure. Most probably they're going to give you some kind of libraries. It will be very obvious how to use them, and probably, so let's say product engineers, let's think about this infrastructure things. But yeah, probably you could try to instate SPIFFE. Maybe it's a good choice for microservices.
Okay. And just a kind of tangential question. Does Java modules, using the kind of module path approach rather than the class path approach, allow you to have more lightweight microservices, or is that still something that's evolving?
Yes.
And there's not a lot of practice on it yet.
Yes, so I don't know any company that really uses Java modules. Probably this feature isn't good enough, so I don't know the reason why it's not unusable. But best practice is to keep your services into different packages. But there are different approaches for this. One approach is telling you should keep your logic based on the layers, let's say controller, services layer, and repository layer. Other approach is saying you should split this by domain. But it depends what would be the future for your services. If you expect in the future that your services will be big enough, then probably you should start this. You should split your services by domains in your source code and put each domain into a particular package.
Okay.
And have a less services should less, modules should less use logic from other modules. So that's only I could suggest.
Okay.
To clarify, okay, thank you. Did you say it makes sense to have 2 free services for each person on a time, or it was 2 free people for each services? Yeah, it's very variable. So in my experience, we have 1-2 services per person. So, but it depends on the complexity. Let's say team could have one big service. Let's say, not big, but a very important service that they make changes a lot into that logic, and they could have a lot of small services that don't support too much. So it depends how much effort do we need. But the rule of thumb, maybe 1-2 services per person, maybe 1 is enough.
That seems kind of more granular than I was thinking. So what's the advantage of splitting up the services that fine?
Yeah, I can't say a particular number, but it's based on my experience. Maybe, let's say, what I see in the companies, what I see that 1-2 service per person is maybe a maximum number. But I can't give you a particular reason for that. It's just a rule of thumb.
Great, thanks.
Wonderful. Do we have any other questions?
Abby, I have one more question regarding this graph. Since Oleg, you mentioned that sometimes it's just better to start with the monolith architecture, but what in the use case when you're using like AWS or Google Cloud Platform services, then you are better off starting right away with microservices, right? I mean, if you need to use something as a queue or some kind of task or email sending.
Yeah, let's have
that. Like, is there maybe some better approach to use monolith instead, or it's just that's like some kind of exception to the rule?
If you have dedicated infrastructure, as you mentioned, AWS, and you really know how to deal with that infrastructure, and you have I don't know, a lot of engineers that could build your services, and you really know how to deal with microservices at the beginning, so it's a best choice. But the problem here could arise that at the beginning, usually when you do a proof of concept project, you don't know how it will end up, so you don't know which logics could be added in your services. And if you start to build with microservices, maybe you need to rebuild it all the time. So let's say if you don't know how your services will end up, so but let's say you build some proof of concept small logic, then you add additional logic, but you don't know which logics will be at the end. So in that case, it's better to start with monolith. But if at the beginning you know that you need to have that particular services, that particular domains, maybe it's better to start with microservices.
Okay, thank you.
Excellent.
Oh, that's really big text.
Yeah.
That's why I haven't seen the full capacity of microservices, and I've always working in an environment that we either use pseudo microservices, is that monolithic apps represents as microservices, or we needed to merge microservices in order to decrease complexity. Exactly on your point about communication between microservices, apart from use cases where more than one framework language is used, and giving the peace of mind that microservices can be easily restarted when we can be responsible. What other advantages do you have compared with monolith?
Good question.
Yeah, the big question. Yeah, so as I mentioned, you could use different frameworks, technologies for each particular service. Also, you make them, you roll out them independently into production. And Yeah, so I can't say what other adventures could be. So I think the biggest adventures is time to market. So if you need to roll out your features with fast paces into production, so microservices will help you. But if you don't need such a fast space, maybe monolithic is easier and it's cheaper to support in some cases. So I say it depends. So I don't know any other reason as a time to market probably. Because as I mentioned, we need to support business. If business is growing, then the company is growing, then salaries is growing, and it's better for engineers.
Great. Any other questions for Oleg? I like that there's been a lot of discussion generated here. This is great.
Yes, I like it.
Yeah. I'm just going to give it a few moments in case anyone wants to put any more questions in the chat. But if you are able to unmute and you've got something to ask, please do. Okay, I will take that as a no, in which case all that is left for me to say is thank you, Oleg, again for coming to share some of what you know. It's been really great to hear from you, and thank you everybody who's joined us today. And if you're watching this video online, I hope you've really enjoyed the talk and the discussion that followed. You can find it all on our London Java Community YouTube page, as I said earlier, and we look forward to seeing you at our next LJC event as well. So thank you so much for joining us today. Take care.
Thank you, everyone.
Thanks.